Hey Terry, how's it going?
All is well. How are you this fine day? Should we
I
talk
need a
about the weather?
I need a fourth hand. If I only had a fourth hand, I could control the volume fade and the video fade all at once.
If I only had a fourth hand.
You didn't even ask me about where my third hand is, so let's not get into that today.
I know where your third hand is.
Moving on. How often are you reading scientific research papers?
You know what? It typically not much. I'd say the past 4 or 5 months, that is a little different because I've been consuming a fair amount of generative information. Um, I did a couple certifications on the stack for generative, and of course, that wasn't satisfactory for me. I wanted to understand a little bit more about the math and transformers in general, and so a little bit.
Was there ever a period when you were uh, in academia or close to academia where you were regularly reading research papers like that?
Oh yeah, I worked in a genetics lab. I've got a weird background, man. We'll get into that sometime. I
So
think
you read science, is what you're saying,
I read science.
but
Yeah.
not the journal science, the actual science you were reading.
I think I think there should be courses mandatory in college as part of a gen ed track, and I'm 100% serious about this, about how to read research papers.
That's legit. I mean, so I have a humanities degree, and it there. So popular economics was having a moment while I was getting an econ degree, and that's just like I graduated right before the 2008 recession, so things got even more frothy in pop economics after I left school and then worked as an economist for a while. So we didn't learn how to read research papers, but but most of the people that were writing preeminent research papers around econ were also, getting interviewed by Marketplace on NPR or, you know, writing a book with the Freakonomics guys or something like that. So there was a lot of very popular literature around this boring, kind of old field of econ. Not a lot of like hard science paper reading. Plus, a lot of papers that are written in the econ field are either tons and tons and tons of math in order to make people like me feel stupid and like we shouldn't be in the field. And then other parts are almost no math with basically like, wouldn't it be cool if this theoretically sound, internally sound theory was actually applied and somebody else should research this. That's my send up of econ
So,
science.
so give me. I feel like, and I want to understand this a little bit. We have other things we're going to get to that we both very much enjoyed today, but I want to understand this from econ a little bit better. I feel like the hard sciences, and I don't necessarily put econ as a hard science, a physical science, but I feel like the hard sciences have testable, provable theories that are both explanatory but also have an action associated with them. And in econ, what's the parallel to that? Is it to explain historically why things have happened or to propose new systems or mechanisms for future iteration?
For the last 30-ish years, most econ research and education and publishing and the field has largely been about how to be how to quantify soft stuff as much as possible. So can you build an experiment where you poll people, or can you measure behavior in a particular way based on observed choices that people make in a controlled or semi-controlled environment? Can you improve the data collection around, things like macroeconomic indicators where we would have asked farmers, how do you feel about the weather, but instead we're going to do something like take actual hyperlocal forecasts and then try and crunch that stuff against grain yields, which then turns into supply side measurement, which then has these downstream impacts of proving the theory around what happens when you have shocks to the supply. So making it more sciencey has been kind of one big project or experiment in econ since like at least the 50s or 60s. Then the other side of it was I kind of sorry, I lost my train of thought. You were asking about testability and whether I know what the other side was. It was the action. So the action side, it's like mostly public policy. So people that are really interested in econ, they're either looking for becoming a business runner, as in I will use the things that I learned about the economy in order to be a business leader, or I will use the things that I learned about and studied in the field of economics to suggest policy action in order to get better outcomes. And that basically falls into roughly two camps. One is we should probably just not intervene and do very, very little, and we should remove all policy. And the other camp, roughly speaking, is
We need more policy.
someone should do something. If only we had a better policy, all of these problems would go away.
So, where would Keynes fit into today's climate in economic theory and research?
Until there was a until there was sort of like a libertarian uprising slash backlash. What I was taught in the early 2000s was that more or less all practicing economists were neo Keynesians. So it was. There's a specific definition to that differentiates the neo Keynesians from the Keynesians. That I would have to reread the Wikipedia page in order to be able to articulate.
Yeah.
Needless to say, I I did not enjoy the academic space in econ because that tension around how do we measure the numbers better, I felt like it was so far away from being solved. And I also observed that on the public policy side, there was this child industry which wasn't really policy making, it was more commenting on policy making. And so if you wanted a job as an economist, the pinnacle of the field was either be a researcher at a school, which I wasn't going to do for a variety of reasons, or be somebody who, jumps around on stage or on camera talking about the economy, which is literally a job in commentary, not econ. And I didn't want to have a job in commentary.
How far, um, pulling back away from econ becomes part of this question. Academia and research generally, on a spectrum of there's a 1-to-1 correlation between academic research and application, the applied, and 0-to-1 academia is bullshit. Where do you, obviously, I don't, probably we both would agree wholeheartedly that neither of those fringes is 100% correct. Where do you land on the relevance of academic research in mass, in total, to the applied benefits for society?
I think that academic research is useful to society and is held back by a number of socio-cultural and institutional obstacles that frustrate me because they seem solvable, but they also seem like it's overcoming inertia and entrenched interests more than it is any kind of like technical solution. So I think generally speaking, the system of some subset of scientists working in a lab to publish papers so that other scientists can review those things, I think that's good. I think that's good in hard sciences. I think it's good in soft sciences. I think that the United States particularly has always kind of struggled with the idea of how do you get that stuff out of the laboratory, or how do you get it out of the academic laboratory. And I don't know, you'll like this. I feel like a lot of the sort of the classic American inventor scientists, there was a lot less of a line between this is the school, this is the lab, this is the commercial application. Like if I'm trying to test rubber grades to figure out what I'm going to make tires out of, yeah, sure, I have a lab, but like every single thing I make is in order to sell products made out of rubber.
So we can't quantify this, but we've danced around this particular issue in a number of different conversations to this point. And George Duvall and the Unimate is the one that strikes me. He had a degree, an engineering degree, but he was by no means a researcher, yet one of the most prolific inventors probably that no one knows. He's maybe not up there with Tesla, but he's mighty close in an applied sense. No research, didn't do research, just built stuff. And I know Talib has a lot to say about this specifically in the field of economics. Do you see can you see as can you assign a value assessment, a ratio of value assessment to applied builders versus academic researchers? Is there a comparison? Is one more valuable? Would builders, do builders even care what academic research is taking place, or are they just making things, building things to make society, to solve problems? And that I'm really interested in that pipeline of research to problem solving to applied, and is that still a viable pipeline outside of pharma? I know
So think about the idea of the ivory tower. So the ivory tower is this far away, just detached from reality, thinking person's insulated land of research and writing papers for writing papers' sake, maybe. I think that that is a valid critique to lobby at academia, but I think you could also say that there's an ivory tower of commercializers. There's an ivory tower of, you know, workaday drones that are just sort of like doing the same thing at the same place. So I mean, I'm biased, right? Because I've had a really wide swath of shallow interactions with a lot of different companies. So I never became, for example, an expert tire maker. So if I had spent the same time that I spent having brief interactions with a large number of different companies in different spaces, and instead I had spent all that time learning the ins and outs of how you make you know, the world's best tires, I would have a hard time being like out of my lane and saying, "Oh, I think that the basic research that goes into AI is helpful." I might have an opinion about it, but the closest I'd be able to tell you is that the basic research that goes into rubber grades and tire mold making is useful because I've seen how that applies to me. But for anything outside of like that tire supply chain, I'm gonna have a hard time abstracting to like what does it mean for somebody else. And this, I didn't plan to try and be in a place where I had shallow but broad interactions, but I'm glad I did, because in the end, it turns out that a lot of people that put their head down and are good at what they do, they just don't have an opportunity to go do a wide swath of different things.
Yeah. Let's pivot to a specific sub segment within this discussion.
It's not going to
Something,
be tires, is it?
no, hell no. That's the underwear of commercial goods. Like crucial, gotta have them. I
Gotta
guess you
have them.
don't,
They
I
get
guess,
better. They get better every year.
yeah. And they're important for feudal economy and, all sorts of things. So I'm just bored with that. But I think we both share an interest in robotics. And I think we both sort of browsed through or perused an article about the convergence of generative AI and robotics um, from MIT. Maybe start. You've been we've been on different sort of perspectives or different. We've had different roles in that game. But you've got sort of a good 30,000 foot view in robotics and automation generally on what is the status today in terms of productivity with robots. Where are the snags? Where have robotics applications been really successful, and where are they held back as of today?
The robots I know best are either a little cart driving by itself through some sort of, either controlled or rarely changing environment. So a factory or a warehouse. I know those relatively well. Think like places a forklift would be usually inside, but inside a big building. I also know industrial arm type of robots, so they may be for assembly or welding or holding material. There's a whole nother world of robots that is, autonomous guided vehicles that are not inside a factory. So this is, self-driving cars, drones and UAVs, underwater remote operated vehicles or ROVs. Like all that stuff is a little bit further outside of my experience with robots. Um, the I think that the thing about robotics is that it's been state of the art for as long as I can remember. but what that actually entails hasn't changed a huge amount. So laying specifically large language models, which is the thing that underlies ChatGPT and Bard and Clyde and a handful of other of these interfaces to an AI, layering that really, 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 really trendy, popular software only thing on top of robots, which are kind of always at the height of public imagination, but also never really very deep in terms of public understanding. I think that's very typical of where research gets done. So it's this thing that is established and is of some interest, but is also sort of like mysterious as to what would make it better. Like what's the next robot look like? And going between a little cart that drives and picks out Terry's Amazon order, and going from that to Rosie from the Jetsons who can go through your house and clean up after you. Like everybody can have this imagination experiment where they're like, where do we go? How do we get next? From, I thought a robot would be a flying car. I thought a robot would be, humanoid made. And then being like processing, well, I have a Roomba and I have a dishwasher and I have a washing machine, but I don't have a humanoid robot made. What gives? I think that's accessible to absolutely everybody in the same way that when large language model becomes on everybody's lips, you can just say, well, everybody's talking about this. Here's what it does. Think of all these things that it can do to solve any problem, and then we'll slap that on top of an industrial technology. And why it's useful almost comes secondary to the fact that it seems cool. Robots, but make it AI. You know what I mean? Like the article writes itself. Now,
Yeah.
am I going to read that article? Probably not, because I feel like I don't need to read that because I already know enough about robots and AI without reading another robots. But with AI, what could we do next? Imagine the possibilities. You know what I'm saying?
Yeah, I think it does present. I think the article does present an application or a use case for generative in this instance that makes sense, because it's what I see as the big win for enterprise with generative, and that's as an augment, whether it's to debugging code or writing programs or debugging programs, whether it be a robotics program or a controller of any sort, a machine controller of any sort. I think with a properly fine-tuned, trained generative model, I think there's a use case for that. But the article references using, and I'm curious. I don't really know if this is a thing, if this is a problem to be solved, or it's vaporware, as they say. But the article references using generative to build a library of simulation task requests that you can use to train. The problem that the article presented was that there were too many sort of use cases in the wild that a robot needs to be trained on before you can validate that its program is effective. And it's too costly to train on all those simulations. So you end up with just a narrow band of applications that a robot's used for. That expands ever so slowly. But what generative the value that generative unlocks is that it creates simulation models, training models for these robots that can be validated or vetted before you go into actual simulation with the robot itself, and you can have a better idea of how the arm's going to perform or how the robot's going to perform with that. So I don't know if that's a problem. I don't know if it's a valid problem, but it seems like there's at least a plausible approach to solving it if it is indeed a problem.
So one of the reasons that I was specifically interested in how do you engage as a regular person with scientific research is the difference between all of the moments that are useful, meaningful science and good research versus the moments that are aha moments or major breakthroughs. And I mean, there's a reason it's called a breakthrough, and there's a reason that not everything is a breakthrough, and there's a reason that we see reporting on breakthroughs as opposed to workaday science. So things like using a large language model to generate a simulated test case for robots in an industrial space, or specifically robot arms, that is research that should be done, right? So the way this works is you pick a very specific way that you do that, and you write up the results of how you're planning, like what's your experimental design and exactly what you used and what it did and what you observed based on that set of tests. And now theoretically there should be, two other peer-reviewed papers that also do either a similar thing to try and replicate your results, or they build on top of your results and they assume that your result has to work in order for them to come up with the next iterative result based on your research. Now, all that stuff is not a breakthrough, right? This is incremental because while you're working on your model, your large language model, and I'm working on my large language model, and you're working on a Terry bot, and I'm working on a Russ bot, these things all happen in parallel, and it's all worthwhile because it needs to be done with all these different test cases. But it doesn't constitute, hey, we're controlling a robot with an AI now. It constitutes, hey, we're making incremental progress on the ability to know the process by which a robot can be controlled with an AI. I went to a lab. I want to say it was Pitt in Pittsburgh. I went to their mechanical engineering department.
Hey, quick
Yeah,
pit
yeah,
stop. Quick pit stop. Sorry. Why is Pittsburgh such a robotics hotbed? I think the average person, I didn't know this. Why is globally Pittsburgh is a robotics hotbed? Why? Carnegie Mellon?
mostly Carnegie Mellon. Yeah, and what? So it's an old industrial city.
Mm-hmm.
There is surprisingly a lot of money there for the population. Um, and more specifically, there's sort of like patronage money. So it's also a big arts and theater city, which is very unexpected. But you basically had, the robber baron era, a lot of philanthropy, and a lot of the philanthropy was aimed at big scientific breakthroughs and, the arts and sciences. Don't quote me on this. I'm basically repeating a Wikipedia page. Also, my mom's family is from Pittsburgh, so I have a little bit of background.
I've spent a lot of time in Pittsburgh. It's the most confusing city in that respect because it's very blue collar mostly,
Yeah.
but it's a proper city.
Oh yeah. 50 days of sunshine a year too.
Yeah, you can have all of that. You can have all that.
So I'm
But
in Pittsburgh. So I'm in Pittsburgh, and I'm walking down the street, and everybody I see is in black, gold, and white. Talk about coordination. All three major league teams, same colors. Like you said, it's a blue collar city, but it's also like a huge sports town. Everybody always shows their colors. I go to the University of Pittsburgh. I had to take like this big freight elevator down to the sub basement where they where they had a bunch of labs, and one of the labs was a high speed camera aimed at basically a drill bit cutting metal, a little tiny block of metal, high speed camera pointing at it. And it was just taking video of what happens as the drill bit goes through the metal. That was it. Maybe there was a temperature sensor on it as well. And I was like, somebody has been doing this experiment with incrementally faster cameras since the first time we had a slow mo camera. And for as far out into the future as exists, someone will still be aiming a high speed camera at a drill bit cutting metal, taking slow mo footage of it. And there's not really an end. It's just somebody's going to aim the ever faster camera to do exactly the same experiment that's been being done, and there's never going to be a breakthrough. But the results are still novel because nobody's ever aimed a camera that fast at a drill bit cutting metal before.
okay,
And like,
what would a breakthrough look like?
so this is specific stuff, right? So think about micro machining. So new iPhone is made out of titanium, right? but most of the rest of the assembly process follows about the same as what it was for aluminum. But there's screws, there are finished edges, all of that stuff. The material science behind interaction of tool and metal, that material science keeps getting better in order to get you to better finish quality, smaller features, and more consistency of your machined metal parts. And if somebody's not continuing to measure, what's the interaction between drill bit and metal look like, you don't get these insights into, oh, well, the heat needs to go into the little bit of metal that's flying away from the part. And it turns out that if you slow slightly down, it will be a smoother cut. Or if you slightly radius the edge instead of having a perfectly sharp edge. One of the things that this is now a very old, I guess, breakthrough in the understanding of machining science is that the edge of the drill bit is not the thing that is interacting with the material that's being removed. It's what's called a built up edge. So as you pass the sharp edge through the metal, you basically get like a pile of removed metal in front. So that pile that's on the front of your cutting edge is now what's driving through the next thing. So that the built up edge of the removed material is acting as your cutting force, not the drill bit that you designed. So now
Well,
you have a completely different set of design requirements.
it seems like that would inhibit precision.
Which part?
A pile of shit being your leading edge of your cutting utensil.
Right, but if you now shape your cutting utensil to direct exactly how the built up edge is managed, you're going to get a better finish because you know that it's cutting on the built up edge. Or you can change the geometry to try and avoid built up edge. Like these are all choices, but the concept that built up edge is what's doing the cutting, that's only possible because of high speed photography aimed at a cut like probably 50 years ago or something like that.
Interesting.
I mean,
So,
it's not interesting at all on the surface. It's a high speed camera pointing at a drill cutting metal, but then you dig into it and you're like, man, there's like there's like 5,000 people who in the world who just sit here and study this stuff and figure out how do I simulate it and how do I aim a large language model at it.
okay, so here's what I like to think about. The person who probably hits the button to start that whole process and then goes to find Subway or
Yeah,
whatever else,
right.
that person's business card seems really important.
That's right.
Really important. I mean, that person is
They're a scientist, Terry.
they're trust the scientist. Yeah, that person is very important. But they push a button that activates a camera that's watching an automated drill operate.
Also, spoiler alert, they don't get lead author credit on the paper. That goes to their advisor.
Oh, so,
So that person that does the actual work of push the button, write the paper, observe the results, collect the results, they do it under the advisement of some schlub who made it to be, a professor. The
that's a
professor the professor has to publish or they're not going to be able to stay in their job. So now they've got their name on this paper, and Joe over there who's breaking concrete to see how the how the cracks propagate, and somebody's like spraying nitroglycerin on plastic. These probably wouldn't be all the same advisor, but they could be. Like, why not?
so I we're getting at some interesting bits of academia and research, because not just anecdotally, and I've seen a number of these instances anecdotally in my field in applied math and applied statistics, where there's a disillusionment with the whole research process, only to then graduate with 8-9 years post grad, 5-6-7 years post grad, committed to this area of research with really nothing to show for it except maybe some debt and a very minimal salary. Those people, I think there's a real sea change underway with people that have the curiosity to figure out how things work. Those people aren't going into the university setting anymore. They're going to work for Google or for other large tech companies. And I think that sort the lines, and we've talked about this before with Bell Labs, but the lines between research for research's sake, but research as a part of a commercial function. I think folks are the people who would fill both of those are leaning more increasingly towards the commercial aspect of it because there's not a lot to offer with what we've been describing.
Yeah, getting into an elite university is hard, particularly in a science and technology field. Getting into an elite university so that you can take classes that are really hard but have been taught exactly the same way for 4 decades from the same material, have no relation to anything that you'll do after school, um, and allow you to then be treated as a second class citizen because you're a student as opposed to a practitioner. It's just not super appealing, even if you can get it paid for by somebody else, which is not always the case.
What's the difference between Oak Ridge or what's the Sandista or
Sandia.
Sandia? What's the difference between facilities like that? Those are government facilities, obviously, but what's the difference between research there or research at MIT or Stanford?
Uh, I mean, so the government wants to fund higher technical readiness level TRL work at its labs. So the idea is you got the lowest TRLs are basic scientific research, which the material science type of stuff that I was talking about would qualify as basic scientific research. The finding that aluminum deforms in this way, titanium deforms in that way. I've written a paper. Here are a bunch of graphs. Here are maybe some heat maps. Ta-da! Results. It's nothing productized. As you go higher up, like TRL 6 or maybe 7, I can't remember the numbers, gets you to this is basically ready to be commercially adopted at a smaller medium scale. And so the Sandias and the Oak Ridges skew towards less basic scientific research and closer to applied research. At least in theory, as of now, I don't know that that's necessarily been the case for their entire history.
I want us to, and let's not let this fall into the abyss of things we say in a show and then it's
Yeah,
gone forever. I want us to really dig into the concept. Maybe it's a week, maybe it's a month. The concept of theoretical research versus applied research,
great.
and where have the big wins come from? How much I know, intuitively, one might think, well, you can't have applied research without theoretical research. I would challenge that notion, and I could very much ultimately be wrong. I would challenge that notion because I think builders make things to solve problems and figure out. There are a number of examples of things that have been built that weren't researched thoroughly, but were very advanced technological applications of principles that had been studied that this person was not aware of. My point is I really would like us to dive into that theoretical versus applied, where have most of the wins come, if it can be quantified, and sort of what's it look like moving forward. That's an area I'm very interested in.
Well, and I think it's important, and I was realizing as we were preparing for this, I'm like I have no intention of being in R&D. Like I didn't intend to know what TRLs were. I didn't intend to have ever been to Oak Ridge Lab. I don't know. I was just worried about how do I solve problems that are interesting with people I like working with. That was kind of my main
Can you
my main
can you take
focus.
a I'm sorry to interrupt you. Can you take a little detour here? You've never explained, and you don't have to name the body or anything like that, but you were a managing director for a standards body
Yeah.
around data. Just explain a little bit about your background and how you've interfaced, why you would have interfaced with labs, and your experience in theoretical versus applied
Yeah.
in that
So,
context.
okay. So I came to work I grew up around DC, went to school in Virginia, came back to DC, found a job at a trade association for machine tool builders. I didn't know what a trade association was, but they hired me with an econ degree and gave me an econ economist title. I was like, that'll do. Great. So that was straight after undergrad. I have a 4-year degree. That's it. So I did that for, I don't know, about 6 years, and it was all sort of like support for sales and marketing departments of industrial equipment builders, some software companies, but at that time it was still mostly like heavy equipment. At the same time that I started, the association's board, basically the same year I started there, the board got together and kicked off this initiative called MT Connect, which was about standardizing data for industrial assets controls, basically. So if I have a Terry brand robot and a Russ brand robot, how do I make these two interoperable with each other? The story I heard a lot was, in the olden days of consumer computers, you'd have to buy like, I don't even know what the brands were, but it would be like you have to buy a Sony monitor for your Sony computer with a Sony cord, and there's no option to mix and match your peripherals at all. And then that all kind of broke open with serial and parallel connections, and then with USB and Bluetooth and all these other ways that you can kind of divide out your stuff, and you have some amount of interoperability. So the idea was, why doesn't the machine tool industry look like that? Why don't factories look like that? The project to create a interoperability standard, that would be something like the Bluetooth or the USB, but for this industrial equipment, that was logically housed at the trade association, because you kind of had a built-in audience for all the equipment suppliers, and the association was a neutral or semi-neutral third party that could essentially coordinate equipment makers to do this thing that cost all of them some money but benefited everybody. And it was basically like a public good type of project. The timing also happened to be right, because there were a bunch of people that had kind of landed at the association and in the board and the membership, who were all interested in this sort of technological advancement stuff. I was just like, I want a job that's closer to computers than what I'm doing now. And I don't want to be a crystal ball gazer telling people what the economy is doing. And I figured I would just take like a little hop, skip, and jump, spend a year or two working on MT Connect if they would have me. At the time, I knew the industry pretty well. So I used that to kind of like weasel my way in. And then it turns out it was a bunch of these computer programmers and mechanical engineers and former, product VPs and stuff like that. And they were all arguing about the definition of velocity versus speed and things like this. And like, I didn't understand anything that anybody said for the first year I worked there. But the guy that had been kind of spearheading this was retiring and needed somebody to kind of pick up some of the mantle. So then I kind of like rode that wave for a while until just a couple of years ago. Still involved, but it's more like a closer to a volunteer basis at this point, not a full-time job.
Yeah. It's interesting. Did you find who were the most productive contributors to meaningful standardization work?
Some random guy who just can't stop. That's all. That's it, across the board. I mean, I was having an argument about this yesterday on the internet with somebody about CAD. They were like, CAD's broken, computer aided design, right? So this is the software that lets you make a digital model of a thing, which you can then use to fabricate it in real life. Like, CAD's broken. Everyone agrees. Yeah, CAD's broken. There's this problem and that problem, the other problem. Well, what we need is we need a federated body to come together and solve this problem. And then somebody's like, you don't need a federated body. You need like one person to do this. They compared it to Blender, which is a mostly open source animation tool. And whatever guy that had CAD background and Blender background, he was like, yeah, and by the way, like most of Blender has been held together by one dude for 20 plus years who can't stop. And so I think this is not unique to what I was working. I wasn't the guy who was holding it together. It was some, the system architect that was in charge of the whole thing. And there was like a top tier of people who were heavily involved. And I was probably closer to like the top tier important player, but it was not like, this was not my brainchild. It was not my baby. It's still not my baby. I want it to be successful, but I don't live with an obsession over changing this industry. I just want to work on stuff that works.
No names, obviously. Who was the most impressive from from a paradigm, from an outline, who was the most impressive person you worked with?
Nobody. They're all like it was a team effort over a really long time. So I've been at least tangentially involved over 15 plus years now, and it was literally, it didn't work because as much as it was built on the back of a person who was obsessed, it was a series of people who were obsessed, kind of one after another. And that to me was an indication that this was a good problem to be involved with, because you had more than one obsessed, fixated person. But I also feel like if you didn't have a bunch of random mechanical engineers who'd show up to conference rooms and argue about the meaning of words, like if they weren't willing to engage in that, the whole thing would have fallen on its face. If you didn't have machine shops and, you know, aerospace manufacturers who like bought into this digital vision of the future before anybody had ever talked about IoT or digital twin or any of that nonsense, like it wouldn't have worked. If you didn't have a board of, you know, semi self-important people that wanted to go like talk about the great initiatives that they were working on, it wouldn't have worked, because you wouldn't have had like the mouthpiece. So it's, and I'm not saying this to be shy or to like demure or anything like that. It just literally would not have worked without a large cast of characters. And I do mean characters. There were and continue to be an enormous number of characters involved in any kind of like public collective project like this.
Okay. We have a choose your fighter segment.
Yeah, do it.
Choose your fighter, and you define the criteria. Standards body like NIST, IEC, MQTT, whatever,
Yeah.
standards body, or academic research facility.
Oh, they both have so much potential for being horrible.
I've worked with both NIST and IEC and can confirm.
NIST doesn't develop their own standards, and they tell you that a lot. So this is what's crazy though to me, is I didn't know that I would ever get involved with, you know, doing like writing papers or co-authoring papers as a NIST co-author, where they have a machine shop that's making parts for actual science experiments that NIST is doing for measurement and standards. And then we also have like a whole connectivity initiative that's at that lab. Like I never thought it didn't occur to me that this stuff was R&D or where R&D came from. Like none of this occurred to me. I just thought it was like, you go make stuff and then that's the end of it. I never thought about it as this is an R&D exercise until I was already, you know, hip deep in it and starting to realize like, oh, this is where R&D comes from. This is where R&D comes. This is why Pitt is different from MIT. This is why MIT and Stanford are a cut above the rest. They have more shops, they have better professors, they have more students who are working harder on more relevant problems, publishing more results and doing less stuff that's repetitive than, every school that's not MIT, Stanford, and like a tiny handful of others.
One aspect that I want to make sure we get into when we get into this topic is the reproducibility crises. That's really a problem in academia. I think there's a lot of pressure, and you just alluded to that with the big players. But I think it across the line, folks' jobs depend on research. So, is the veracity of every scientific paper you read, can you trust it? And I think there have been a number of very high profile cases over the past 2 to 3 years of very flagrant violations of.
I was just reading about this
clauses.
week. There was some big hypothesis. I stopped following econ stuff a while ago, but there was some very widely cited result from a behavioral economics paper, and somebody tried to reproduce the result and was like, "This is just autocorrelation. You structured your experiment wrong, and you correlated a variable with itself. Fools." And it's like, this was years ago that this thing came out, and now it's being not debunked, but it's being turned back over again.
Well, there was also a case. This is just a summary because I don't have the details at recall, but there's a very senior Stanford professor, maybe even a dean, that has had years of research debunked for veracity issues. And I think I, it's why I think that there should be a mandatory course in college for as part of a gen ed track where you learn how to read research papers, because I think even folks that don't specialize in research, the more they understand what it is that they're reading. And I think this is big for health and fitness and for longevity and some of
Mm-hmm.
the things that we talk about. You can't take just anybody's word. Your health, your family's going to tell you some wild stuff. Figure out how to read the research and sort of distill out the key tenets of papers yourself. I think that should be mandatory work for students. And I think the more that happens, that I think by default puts extra scrutiny on the veracity of the research, and maybe to some measurable degree will help curb some of those things.
I'm optimistic about the system, right? The system is supposed to be you publish the results, you have to show the findings, you have to show the methodology. Every paper is structured approximately the same. You have an abstract, you have an introduction stating the problem, you have your design methodology, you spend the bulk of the paper talking about how you did your experiment, and then you draw brief conclusions in 5 to 8 paragraphs at the end of the paper, and then you have a long list of citations. And if you don't end up as somebody else's citation, and if you didn't cite, then you disappear from the literature because you wrote something irrelevant. That system is pretty sound. The problem is it was set up that way, I think, semi-intentionally. Uh, uh, it was set up to make it so that you could have some consistency and know, like, this is legit, this is not legit. And if Terry and Russ decide to write an AI paper and we don't cite to any sources and we don't have proper footnotes of any kind and we don't follow the format of abstract, introduction, experimental design, results, key findings and recommendations, if we don't follow that, it's one paper less that everybody who's worried about AI has to go read. And if even if it's really good research, if we haven't followed the basic premises of peer reviewed research, and all of our peers and whatever that thing was are all in academia, it's on us to write it in a way that's going to work. But that ends up being a gatekeeper because a regular person has to read this like crazy dense language, has to understand what citations are. There's like 1,000 different publishers and systems of record for where this stuff would be, understanding that a journal paper and a conference paper aren't the same thing. Like, it's so convoluted. And then all the convolution and process stuff ends up getting in the way of just being able to read the science for a regular person. So on one hand, totally worth it to figure it out. On the other hand, once you do figure it out, you'll feel like, I need to stop reading the, I don't need to read the distillation of this research into an article. I need to read the research. And if I can't understand the research when I read the abstract, who cares? Go find the one that I can read and understand the abstract, or go seek out the people in the citations and be like, what did they write? Maybe understand some of their thing. Go on Google Scholar and search keywords and see if there's some other paper that's less pages long and has a title that you can follow, because there's always something that you can get. I don't know, that it's very easy to hide behind seeming smart and seeming complicated, and there'll always be another space at another school or another institution of higher learning for somebody who uses big words, publishes a lot of papers that say nothing, but they're contributing. They say big words, nobody's calling them out. Like, everything's fine there. There'll always be another spot like that.
Is there a bigger bug in the system than funding source for theoretical research?
No, I mean, I see it as systemic. The things that are wrong, like, I'm optimistic. I feel like this is basically the best it could be. There are systemic and systematic problems where there's less good research than I would like, more crap research than I would like, more repetitive research than I would like, and far less interaction between a typical academic, especially at the undergrad level, but anybody who's writing a senior thesis, a master's thesis, or a dissertation. Things like survey 10 people from industry who have experience with the eventual application of whatever thing it is you're working on, and do that at the beginning of your research. Yeah, that's the fact that that doesn't exist is because there's systemic siloing of this is academia, and that's different from government labs, and that's different from industry. So the silos self reinforce and make it harder to get that cross pollination. I think a lot of people have observed that knowledge transfer to industry matters. It's just inertia is let me go be with my academic friends, let me go be with my industry friends. Please don't make me try and figure out how the other side is operating. I think that's more of an issue than where does funding come from for basic research. There's a lot of money flowing to basic research.
That's fair. I think my last question for you: would you like a business card that says head of R&D?
No, my business card. Here's my business card. I have it right here. I've got a good title on here. There you go. The whole internet. Call me whenever you want. That's the whole card.
Russ Waddell.
Name, where to find me. If
Yeah.
you need to know, you'll need to know.
I like it.
Anybody can do this. This is my last point. This is like the one takeaway. I feel like I backed into it. Anybody else can back into it. All you have to do is read a paper. And I know other people that have no advanced degree, and they're in the research world. Not every day, not all the time. They don't work at a university, but they are doing research the same as Thomas Edison and Harvey Firestone were doing research at their summer lab in Fort Myers, Florida.
But I wonder, another topic for when we get into this.
Anybody can do it.
Yeah.
I'm not special. Publish your results, learn in public, be respectful of the people that you're trying to learn from, read, have a thirst for knowledge. This is all I'm not making any of this stuff up. This is not new information.
Circle back.
Go to some random school, ask if you can see their lab, take your kids. Try not to waste their time.
It really is. I worked in a very small university genetics lab, and I think folks should at least tour labs and go see. Like, it is, I mean, maybe it's boring for most people. I don't know. But for me, the process is fascinating. It's something that I think people should get more attached to research and how to consume it, how to be a consumer of research, the output, but also like an appreciation for how that process takes place.
It's right there. Anybody can do it. Reach up and grab it. Maybe we'll come up with, maybe we'll take some more action oriented. How do you put research within grass? Maybe we'll have some people on and maybe find a link dump that where to go to what steps to take next.
Well, we're not going to let this one disappear into the ether.
See you next time.
Have a good day.
Bye, Terry.